Alright guys, today we are talking about this little guy right here, and that is of course the 16 by 2 LCD screen. I'll give you a little closer look at these pins here if we can get it to focus. Alright, we're going to start with pin number 1 on the left, VSS. That's your positive 5 volts. VDD is your ground. VO is your dimming. RS, read write select, I think. RW, read write. E is enable. D0 through D7 are your data pins. And A and K are the backlight. A for anode and K for, I don't know, the Cyrillic spelling of cathode. All right, let me give you a look at the back of this boy too. Now this is a parallel device, but we'll be sending data to it serially. It's not really that hard. Let me show you how to hook it up. Bring in the breadboard. And as you can see, we have a potentiometer here. You need that for the contrast adjustment. Plug her in right here. We have power and ground coming from the Arduino there, because you're going to need a lot of power and ground connections, so it's good to have a bus. So we will start out with VSS to plus 5 volts. And VDD to ground. All right, V0 goes to the wiper. VO goes to the wiper. That is the center pin on your potentiometer. And since we're over here, we'll just go ahead and plug our potentiometer into plus 5 and ground. Pretty simple so far, right? Okay. The RS pin goes to D12 on the Arduino. The RW pin, this is your read-write select. We're not going to be reading from it, we're just going to be writing to it. So it goes to ground. You want to hold that one at ground. And the enable pin goes to digital 11. Now, D0 through D3 we are not going to be using. They can be used, but it's easy enough just to use D4 through D7. So D4 goes to pin 5. I'm sorry. Yeah, that's right. D4 goes to pin 5. D5 goes to pin 4. D6 goes to pin 3. And D7 goes to pin 2. And finally, the backlight power. The A for anode goes to plus 5 volts. And the K for the strange spelling of cathode goes to ground. And that is it for the hookup. Let's pop over to the PC and write some code. Alright guys, the code we're working with today is contained in the liquid crystal library. So if you don't have that installed, make sure you do through the library manager. If you don't know how to do that, check out my video on it. There will be a link to it in the description. Alright, so if you follow the first part of our video, you know how to wire the stuff. But they give you a little reminder here. Okay. Now this is all public domain, so you can see the people who put in the work here. And let's start with our code. First thing we need to then do is include the liquid crystal library. Next, you initialize the liquid crystal and you tell it the number of the interface pins, where to look. Next, we're going to come down to our void setup, and you begin the LCD by telling it the number of columns and the number of rows. And then you use the LCD print command to print something. Here it just says hello world. Now this is in the setup, so it's only printing at one time, but it could be in the loop section as well. So down here we're doing a set cursor to column 0, row 1. And remember, dealing with binary stuff, 1 is actually the second. And then it's just printing the number of seconds since we started. Okay? Very simple. Now, here is the code that I have created using this other library code. That contains all of the commands for the library. You have auto scroll, which will allow text to scroll horizontally across the screen, and then you turn it off with no auto scroll. The same with blink, in case you want to annoy everybody who ever sees it. And again, you turn it off with no blink. If you want to see the cursor, you turn on the cursor, turn off the cursor. Scroll display left, scroll display right, set cursor, LCD right, LCD prints from right to left in case you're writing in Hebrew, left to right, and of course the LCD print command, which you can use to print variables, text, strings, whatever you like. So I will post this code so you guys can get a look at it. And we're going to go back to the example one last time, and we're going to pick up this one called serial display, which allows us to type things into the serial monitor and they get printed onto the LCD. So up here, absolutely nothing new in this section except serial begin, so we can begin our serial comms. And then when we come down here to the loop section, you can see where it says if serial is available. That's just making sure the serial port is open. Clear the screen, and we're saying while serial available is greater than 0, which means while there is data coming across the serial port, we are going to write each character to the LCD screen. So as you type in a letter into the serial monitor, it is going to appear on the LCD. Pretty simple, right? All right, let's go back over to the lab table and have a look at how it all goes together. All right, everything is hooked up and we've plugged it into the Arduino and plugged into the computer. And we can now use the screen. Pretty cool, isn't it? There are so many things that you can do, and learning how to use one of these 16:2 LCD screens is probably one of the best things you can do in your Arduino learning. You can use this to send it, or to receive serial data. You can use it along with a Wi-Fi shield or an Ethernet shield or a Bluetooth shield to send or to receive data from sensors, phones, the internet, just about anything you can think of. And again, my words of advice are don't mix up these last two, the anode and the cathode, for the backlight, or you'll blow the whole thing up, and that will be the end of that. I speak from experience. Don't ask me any other questions on it. That's all I'm saying. If you like this kind of thing, please give me a thumbs up, share with your friends, share on websites, share on blogs. And if you haven't subscribed yet, what are you waiting for? Catch you guys next time.